The overall goal of this protocol is to demonstrate the correct preparation of solutions that are to be used in diverse genetic engineering laboratory sessions by using different concentration calculations, as well as the correct handling of laboratory equipment and material. It is important to know that there are a number of ways to express the relative amounts of solutes and solvents in a solution, or percent composition. We can consider percent by mass, or weight percent, in two ways: the parts of solute per 100 parts of solution, or the fraction of a solute in a solution multiplied by 100. For this, we need two pieces of information that will calculate the percent by mass of a solute in a solution, the mass of the solute in the solution, and the mass of the solution. Molarity tells us the number of moles of solute in exactly 1 liter of a solution. We need two pieces of information to calculate the molarity of a solute in a solution: moles of solute present in the solution and the volume of solution in liters that contains a solute. Molality tells us the number of moles of solute dissolved in exactly 1 kilogram of solvent. We need two pieces of information to calculate the molality of a solute in a solution: the moles of solute present in the solution and the mass of solvent in kilograms in the solution. It is important to know that there is a relationship between normality and molarity. Normality can only be calculated when we deal with reactions because normality is a function of equivalence. The normality can only be determined by examining this reaction and determining the proton exchange and multiplying molarity by that number. When we're talking about parts per million, it is commonly used as a measure of small levels of pollutants in air, water, body fluids. Parts per million is the mass ratio between the pollutant component and the solution. When we're talking about stock solutions, we are referring to a concentrated solution that will be diluted in order to work with a lower concentration. These serve the purpose of saving preparation time, conserving materials, reducing storage space, and improving the accuracy of solution concentrations. It is necessary to calculate the volume which will be needed in order to achieve a desired concentration.
Before preparing a solution, it is necessary to learn about the reagent characteristics. For example, not they are corrosive, irritant, explosive, toxic, or more. It is also essential to realize if they are in liquid or in solid form, if they are photosensitive, and whether they are hydrated or not, because this could change the calculations that were discussed previously. As always, the storage conditions are important, such as temperature, molecular weight, and supply information could come in handy in order to approve the forming calculation for the reagent used. This is necessary for both work, as well as a stock solution. It is important to check the protocols that will need a certain solution, the amount that will be needed each session, and the number of times that it will be utilized, so as to assert the volume calculation that can cover the necessities of the desired solution. It is recommended to prepare at least 10 times what is needed in order to have a reserve, in case there is a mistake or a protocol that has to be repeated.
Before preparing a solution, it is necessary to check whether a pH adjustment is needed, as well as the solution with which it will be adjusted. For example, the most common pH adjusting solutions are hydrochloric acid, acetic acid, and sodium hydroxide. It is also vital to consider the volume in which the solute is to be dissolved before the pH adjustment takes place, due to the fact that it has to be a maximum of 3/4 of the final volume, so as to reach the final desired volume once the adjustment process is completed. If the final volume is not reached, it is normally completed with distilled water, depending on the solution. Also, it is essential to determine which is the most appropriate sterilization method for the desired solution. This is used to avoid microorganisms growth and contamination, guaranteeing durability. And it's also recommended to use distilled or deionized and sterile water for the preparation of all the solutions. If there is need of enzyme uses, it is necessary to use molecular biology water, which is nuclease-free.
Labeling a prepared solution is key for preservation and avoiding accidents. It must include the solution name, composition, and the person or group of people who prepared it, as well as the date on which it was made in the most orderly fashion.
The solutions that were prepared require previous calculations in order to know how much solid or liquid, depending on each case, was to be taken of each reagent in order to abide by the designated concentrations. It is important to mention that a couple of them were taken from stock solutions.
Knowing molarity, we get moles. With moles and molecular weight, we get grams. With the known percent, we get the new grams for the 12 milliliters. We know volume and concentration of the solution we want to prepare, and calculate volume for the 1 molar solution. The solutions that were prepared are glucose 1 molar, glycerol at 10%, calcium chloride 0.1 molar, just hydrochloric acid 1 molar with a pH adjustment, sodium hydroxide 5 molar, ethanol at 70%, TBE buffer at 10x concentration, TAE buffer at 50x concentration, loading buffer, TE buffer, sodium acetate 3 molar with a pH adjustment, SDS at 20%, phenol chloroform isoamyl alcohol with 25-24-1 proportion, ST buffer, and a GTE solution.
It is of great importance to understand the diverse facts needed in order to work properly with reagents, as well as the correct calculations in the diverse concentrations unit to obtain the desired volumes. May it be calculations of molarity, which is equal to the mole of solute over liter of the solution, the molality equals to the mole of solute over kilograms of solvent, the normality equivalent weight of solute over liter of the solution, or the percent, which could be volume, weight, or weight, amongst others. If we have a stock solution, we have to make use of a dissolution calculation, which is equal to the concentration 1 times volume 1 equals concentration 2 times volume 2. Furthermore, the correct handling of material and equipment, as well as cautiousness regarding the reagents, is essential for a good protocol.